We go through it again step by step, how to graph a quadratic equation in the form y equals ax squared plus bx plus c. This one is definitely in that form. Step number one, first point we want to find is the what? Vertex point. So I've got x equals negative b over 2a. So I have 2 divided by 2. The x coordinate is going to be 1. Everybody good there? You get 1 for the vertex point. To find the y coordinate, we're going to take this 1, we're going to plug it in right here. So I've got y equals 1 squared minus 2 times 1 minus 2. So I've got 1 minus 2 minus 2. So I've got a positive 1 and a negative 4, which gives me negative 3. So my vertex point is 1, negative 3. Good? Is it a maximum or a minimum? It's a minimum because A is positive. So that means that this vertex is a minimum and my parabola is going to open up. The next thing that you do is you put your vertex on the graph. So I've got 1, negative 3, which is located right there. I have a vertex which is below the x-axis, which is a minimum. It opens up. It definitely crosses the x-axis. Has to cross the x-axis in 2 places in order to find the x-intercepts of any function with a y be equal to 0. So I have 0 is going to be equal to x squared minus 2x minus 2. That is not factorable. So since it's not factorable, we're going to have to use the quadratic formula in order to go ahead and find out what these x-intercepts are. So I've got x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Everybody have their calculators handy here. Okay, we're going to need them in a second. It gives me 2 plus or minus the square root of negative 2 squared is 4. Negative 4 times negative 2 is positive 8 all over 2. So I've got x equals 2 plus or minus the square root of 12 over 2, which means I've got 2 plus the square root of 12 divided by 2. I've got 2 minus the square root of 12 divided by 2, and this is where your calculator comes in handy. Okay? I'm going to take the square root of 12, which I'm assuming is about 3.4. Anybody do it? Square root of 12, about 3.4. Add 2 to that, we've got 5.4 divided by 2, come out about 2.7 something? What is it? 2.73. So we got 2.73 and 0. That's one of my x-intercepts. And this one here, negative 0.73 and 0. Okay. This is negative 0.73, 0. There's my 2 x-intercepts. The only difference between this one and the one we had done previously is that previously the quadratic equation was factorable. This one was not. As I mentioned in chapter 1.7, you have to be able to solve quadratic equations using all the different methods. Next thing we want to do, we want to find out, are they right? Well, there's one way we can kind of eyeball it to check. 2.73, here's 1, 2, and almost 3. And negative 0.73 is almost to negative 1. Here's my vertex point. I've got a point 1.73 units to the right. I've got one 1.73 units to the left. They're right where they're supposed to be, so they're good. Last thing to find is our y-intercept. How do you find the y-intercept? Let x be equal to 0, but as we mentioned before, when they are in this form, c is going to be your y-intercept. The y-intercept of this graph is going to be 0, negative 2. 1, 2, there's 0, negative 2. Well, if I have a point at 0, negative 2, and my vertex is here, then I must also have one at 2, negative 2. And once again, this point comes from symmetry, okay, from symmetry. I've got a point, 1 unit to the left, negative 2 units on the y-axis. I have to have 1 unit to the right, negative 2 units on the y-axis. I've got 5 points. Got a nice parabola here. We're going to go and connect those particular points. Again, this is going to be a smooth line, as smooth as I can make it here. Going to hit, there's my turning point. Coming back up through here. And there is the graph of y equals x squared minus 2x minus 2 using the procedures that we outlined here. Okay?